So question 9 wants us to put this algebraic fraction into partial fractions, and then it wants us to expand it using the binomial expansion. So to start off, we know that the fraction, they've actually given us the form that it would be set out in, so we just put them equal to each other. And it's important that it's, because it's got this repeated root here, the powers ascend, mustn't forget that if they ever ask you to do it yourself. So now we can add these together so that they've got a common denominator, and then the numerators will equal each other. So 50x squared plus 38x plus 9 will equal a lots of 5x plus 2 times 1 minus 2x. They're the missing factors from that one. Plus b lots of 1 minus 2x plus c lots of 5x plus 2 all squared. Now, some people like to substitute in values of x to make certain terms of this equal 0. That seems to be the more popular way to do it. The other way of doing it is to expand the right-hand side and equate coefficients of x squared, x, and constants. We're going to do a little bit of both. So if I start off by substituting, saying when x equals minus 2/5, if I substituted it into this bracket here, that would make that 0, and the same with this one here. So that term and that term would both equal 0, and I'd just be left with this middle one. And if I substitute minus 2/5 into this left-hand side, I get 9/5. And if I substitute it into this bracket here, I get 9/5. So 9/5 equals 9/5b, so b equals 1. The next one I can substitute in is if x equals a half, that would make this bracket and this bracket equal 0, so that term and that whole term there would disappear. So when x equals a half, if I substitute it into all of this, I get 72. And if I substitute it into this bracket and square it, I get 36. So that gives me that c equals 2. And then lastly, I'm just going to pick a nice value of x and then equate the coefficients. Oh, in fact, I won't even need to equate the coefficients. I'll just be able to use my values of b and c. So if I choose x equals 0, that seems like the easiest one. This side would be 9, the left-hand side, and I'd have 2a plus b plus 4c on the right-hand side. If I substitute in b equals 1 and c equals 2, that leaves me with a equaling 0, which is nice. So my partial fractions in the end are, we don't actually need to write it out because the question just asked us to find b and c and show a, but it's quite nice to have them written out for our second part of our question. So 50x squared plus 38x plus 9 over 5x plus 2. So a is 0, so we don't need to write that one. It's 1 over 5x plus 2 all squared plus 2 over 1 minus 2x. So part B of the question asks us to use binomial expansions to find P, Q and R, basically. So we want to expand this fraction separately to this fraction. So I'll go over here because I'm going to need quite a bit of space for this. So I'll start off with 1 over 5x plus 2 all squared. I'm going to start off by writing that as 5x plus 2 all to the power of minus 2. Now, my expansion only works when I have a 1 here. So I need to take out a factor. So that's going to be 2 to the power of minus 2. I'm also going to just swap these terms over so that it looks like the expansion that's in my formula book, as that usually makes it seem a little bit easier. I'm going to have to divide the whole of the inside of the bracket by 2. And I've swapped the constant and the x in there. So now I'm ready to use my formula. So 2 to the power of minus 2 is just a quarter. I'm just going to leave that out the front so that I can multiply it in at the end. And then this is my expansion ready to go. So I've got 1 minus 2 lots of 5 over 2x. So that's like, you might have wondered where I got that from. It's because I did that. So it was minus 2 lots of it. So that's my power. And then the next term would be minus 2 times subtracting 1 from the power, all over 2 factorial, 5 over 2x, all squared. And it only wants me to go up to my squared term. So then if I simplify all of this and times my quarter in, I get a quarter minus 5 over 4x plus 75 over 16 x squared. Now I'm ready to go to the other fraction, which was 2 over 1 minus 2x. So again, I'm going to rearrange that and write it with a negative power so it looks ready to go. So this one has a 2 out the front, ready to be times in afterwards. So I get 1 plus 2x plus minus 1 minus 2 over 2 factorial, so 2x all squared. That 2 there came from me doing negative 2 times the negative 1 that was the power. And then if I expand all of that, I get, and multiply the 2 in, I get 2 plus 4x plus 8x squared. Now, all that's left for me to do is to add this expansion here to this expansion here, because we want the sum of the 2 fractions. So all together, it's works out to be 9 over 4 plus 11 over 4x plus 203 over 16x squared, and that's my final expansion. The second part of part B wants me to find the range of values for x for which the expansion is valid. So that is when the denominator of the fraction, the modulus of that is less than 0. So that would be when the modulus of x is less than 2/5.